This style is wrong. Today I would like to share about a topic about the object-oriented programming for database in Python. And is it okay for you to ignore don't use SQL directly to in your Python application? You just use everything in OOP manner to manage your database. Um, okay. First of all, we would like to review some core concept in database designs and actually each befit you learn something on database normalization, design pattern, whatever. But this is quite this is a other explanation from OOP style to solve the problem for database. And in fact, it is not necessary for you to write any SQL if you learn that how to use OR mapper to in your program language or framework. It will solve your problem. But before that, you will have some common problem. Is that how can you design and create your database architecture, or for example how many table, how many field. And I would like to share some step. And basically it's quite straightforward. For example, here is an cases that you want to modify a bar system. Okay, you have a bars, and then first you have only two steps. First step is you count for the entity, something in noun or realistic. For example, in this picture, you will think about this bar system. You have some beers and have a bar, and then you need to verbally or write down some relationship sentence. Just jot it down. If you are good at English, it's quite straightforward. Just write it: bars sells beers. Then you know that bar is a noun here. You count it for entity, and then it is a plural form, and then the relationship between bar and beer is you can model it as a sales relationship. And then this is the first step you do the database design. You try to analyze your system and then write down all the sentence, and then extract the noun is the first step. Then investigate there's a bit more pattern, but in general, you know one to one to many, and many to many. Then you can resolve both of the real world problems. There's some hybrid case or the minor difference case that is quite straightforward to solve. For one to one is for example, you model a marriage system in Hong Kong. Hong Kong is it's in the case of one man and one woman to marry together. Then quite straightforward. If you don't want to do some this kind of data modeling, you just try to write down your data record in spreadsheet or just in a paper. For example, in this style, this is a man table, there's a woman table, husband table, or wife table. Yeah. Then you try to connect it together. You need to add extra column. But for this case, for one-to-one cases, you can add in the relation, say marry, man marry a woman, or divide, or reversely, you can say marry two. Put the column in the right table. It does not matter for one-to-one. Um, but you need to think about this data structure, any requirement you need to solve it. For example, you really worry about is this any duplicate column, is it any empty column, and the relationship number. Just discuss it one by one. First of all, for every table, you just need an ID column. Okay, you don't have to do something redundant. For example, wife ID, husband ID. The table name imply this as a prefix, and you don't want to have this data be stored in your database. For example, the the room the man marry a woman, the number, the ID is 6, but 6 is not here. Maybe it is impossible, and it is maybe a ghost. You don't want a ghost story, and so you will set up a foreign key constraint so that you can prevent this kind of problem. It will not be able to input 6 into the wife ID column, and then you don't want to have this kind of happening. For example, if in the man table, on the man table, husband table, you got the come appear two woman ID. Oh, it means that a woman with two husbands. This is wrong. There's a reason why in PSA we need to be unique. Okay, so to prevent the duplicate input, you will also set the constraint so that unique key index added to there, so that it makes sure the design of database this column will not be repeated. And one more consideration is that will you be allowed to be and mandatory requirement if you want to have this condition. The baby just born, a man, a boy, they need to have a right when they born. Then you need to make sure this column is not null. Is it nonsense? Is it not logical? A baby should not have a right. So for this condition, we will set up a condition say this is nullable. Okay. And this is database design logic. And now we would like to show you how to model it in Python using the SQLAlchemy. And then you will have the Python code through the ORM framework, and then generate the SQL statement for all the database manipulation, from create table, update data, insert data, delete data, curate data, everything in Python only. Don't need to write any SQL statement. And for the SQLAlchemy version 1, and some of our project is still using version 1, not yet updated. So you just quite straightforward. User own a phone, one-to-one relationship. This is our model. You just create an ID. Every time create an ID and table name. Everything create an ID in the phone table, and table name is phone. Then you just quite straightforward. In the user classes, you add a field called that so-called relationship phone. Then you told the SQLAlchemy that is a relationship, and then you don't use list. If you use list, it implies multiple. Okay, you use single field and not notable. You always have it. Want to run, this one is not null, and it means a user must have a phone. And then reversely, the direction, you just also add the relationship so-called user, also point to user, and then it is not a list, it's just a single item, and then populate back to the phone field. You need to make sure don't have spelling mistake here, since it's not able to check it's a string. However, you also want to ensure the foreign key constraint. I just mentioned before, you don't want to have a phone with the user ID is not here, someone at depth already, or someone not exists in the system. So we have the foreign key constraint here, but this one is not notable. For the official document for version 2, there's another somewhat private trial style, but in the version 2, you have a better syntax, is that you can have a map that classes to wrap the type. In the past, you need to mention it, this is integer, this is integer, this is integer, something like that. But here, we just need to have the syntax changes, and then also this is quite similar pattern, but just have the map that here, and then the column name is changed to map the column, and then you can define the one-to-one relationship. And another one is one-to-many. And in the ancient time or the past, long time ago, the king can have many wives. Okay, so you have a man have many wives, and so you need to model this data. You need to think about how can you model this. It's quite straightforward. You just need to write it down. Just write down. You open a spreadsheet, Microsoft Excel, and then you just try to type it down. You will find that if you put the column in the husband, it means a woman can have many husbands. But if you put the multiple one, the married to relationship, married to, and then you just put the number here, you can represent one row of data in the man table, and the multiple row table, row woman in another table, the woman table. Okay, this one is more simplified than the last one. The last one is more complicated one, many constraints. For this case, you really do the same thing and with the same logic. For example, you don't have to do something redundant, husband ID, just ID, okay? But for the case, you can't reverse the column both sides. I say 1 to 1, you can put the column in the husband or in the wife, no difference. But in the case, you must put into the multiple one. Okay, the woman is the multiple one, and the foreign key constraint. You also don't want to have a husband not exist in the right table, otherwise he will marry a man is not exist in the realm. And also, you need to think about why it's possible to have a husband when they are baby. just blank. It's not make sense. So you will also allow null for this column. But finally, you no more have the unique key index need to set up like the previous case. Since this is able to repeat, you don't have to be unique here. Oh, now we go through the Python is very similar. Just train a miner for version 1. You did here by default it's a list. You just let it is list a comment. A post have many comment. But this one I think it has a minor typo here. So this one should be a this one is wrong. This one should be same as the previous one in your reverse direction. You need to have a post here. Yeah, I just have a typo here. Yeah, you just need to do something very similar. You need to have a reverse direction since for a blog post you have a comment. A comment have only this only stick only related to single post, and reverse direction is a list. You need to have this condition for the comment and post. But you see that comments pros don't have the typo here. Yeah, comments here, pros. And then just very similar to this one, you need to set up a foreign key. Okay, otherwise the pros may not be the comment must have a valid post ID, so you need to have a foreign key constraint. And then the column is post ID column. You see here and here. And okay, this is model 1 to many relationship. For the version 2, you have this setup. Just the build a bit to train in the syntax. You just rewrote the document. Say use a mapper column and then type here, and the list of children. Okay, so one parent had many children. One and then reverse for a children only one parent. So this just directly just put a parent here, and then so the total relationship is table parent here. The reverse relationship parent. This is parent. This is parent. This is children. You see a course here. You need to define something like that. Then you will complete the OR mapping and the foreign key constraint. Don't omit it. Now this is the final one. The final one is the something very crazy route. You got a unknown places, maybe other planet. It's now every man can marry every time, woman can marry to different men many times. No rule at all. For example, you just type it down. You will find you need a table called the marry as a relationship. You got a man 1 got 4 2 3 okay 3 wife, and then for a woman number 2 BBB got 1 3 4 1 do you see that B is 2 1 3 4. Okay, you see the logic is quite straightforward, and this is mandatory have a table for the association or the relationship. Okay, somehow we need a bridge to connect it together. But the logic is even simpler for the many-to-many. First of all, you have a table that is the man ID and woman ID. Okay, man ID and woman ID, the middle one. Man ID and woman ID. And you need to have the primary key combined together for a table, as you don't want to have this happen. If this is allowed, it means that they can marry twice or triple time, any number of time marry. This is not making sense for marry only a single time. For default, just delete it. It's not making sense. And you can set up 2 foreign key for you. Remember, you need to set up 2 foreign key. Otherwise, similar logic, the other things, you will have the chance to have a woman not exist or a man not exist here. Then they marry with a ghost or with someone not in the realm. And this is the simple source code for the version 1 for SQLAlchemy. You see this is quite similar. Just remove, just you need to have a additional table called association with one table, and then you define a column user ID here, row ID here, where one user can have many row, one row can have many users. Okay, so you just put it down here rows, but this time you need to have a secondary association table so that it will join it together, and then from this the field from the so-called row here is probably back to user view is here. You see the course here. This is quite interesting for SQLAlchemy. You always divide course here. This is the rows user, then you finish your many-to-many relationship. For version 2, the syntax is minor changes. You just put the column here, run key here, and then you told them this is primary key, and then the child relationship, parents relationship, then you many child, many reason, but also put the secondary here. They will draw the table for you automatically. Believe in me, SQL is very complicated when it's drawing table. But now you see that if you already well define this ORM mapping in your Python classes, you will be very easy to have any join tables in. You can just say typing your autocomplete, just dot parent dot something. You got your all children, and then children can dot for the comment for them, post for them, phone for them, whatever. You can very easy join many table. This is the problem of ORM is it may not be optimized for the performance, but for developer will be very confident. Now finally I would like to have example for database reverse engineering. You have learned this kind of technique before through some database courses, or the so-called normalization or something. But I believe in that this is very theoretical in the past, and in fact this is something quite straightforward and very common in your job in the realm. Your boss sometimes just told you that just clone other website or apps from other company, or clone or merge, combine few apps together to build a new apps. This is very simple. It's a very common case every time I do that. You need to extract the existing system, reverse engineering into the database structure. Formally with so-called normalization, but for the real world, you can have some trick and step to resolve the problem by your common sense. It will give you similar output. And first of all, I just highlight some steps for you. You will have some user interface, and then you need to circle down all the data field, changes field. Something you feel it will change, then you highlight it, circle it, and then you highlight some input field and drop down. You group it together, it will be a table. Normally, drop down will imply a table with joy, and think about the name and group them together. Since you will see something very similar, you will need to group them together. Maybe it's two tables with share same column, then you combine them together, add extra column, say woman table and man table. Shall we make a human table or person table, and then add additional column, so-called male and female gender column? Then you can combine the table together. That's the trick. You need to, if you create many table very similar columns, just combine them together. And remove repeated calculated fields. It is not making sense to show the age, or the age should be calculated based on date of birth, and then deduct from the now today to count it for the age. Also, the total of the amounts of payment or total bill payment, this is calculated by sum up of the item and price, cost price. Yeah, this is not making sense to have calculated view. You need to ignore it, but you need to bear in mind later you need to calculate it. And finally, you need to combine some repeat table I just mentioned before. The table very similar. Combine it. Is not making sense to have many tables of similar column. Not make sense. And then you have one to one to many, many to many, or one to one many, one to zero many. You there's some hybrid now or not. Just think about it. Here's the example. I want to reverse engineering this website AWS training. And you have this screen. You try to just, I said before, highlight this kind of option. Okay, something will change. Something can be changed. This will be a hint of the table. A table may be a row, a table may be domain, may be language. There's a hint. If anything drop down or selectable will be a small table. And finally, this is table, but this is maybe, but remember, this is the data. Skill level is the table. But the data there will be fundamental, intermediate, because some row of data, 3 row is there. You need to think about it. And okay, we got some small table. And then, but this digital is not making sense. You see digital here is you have no idea what it is, but you need to think about it. And also, next screen, you just try to extract the data from every screen. And highlight here. Oh, got it. And then you select some field, and here is something selecting, maybe the date is the data, and here is some field there. We'll extract the all digital and classroom. So we can summarize digital no more makes sense. This is course mode. You need to summarize yourself the role of the courses, and then for every courses you see the screen, there is a name, this is something, and here course description, number of them, and arrow. You need to drill it down, continue to click on the screen, and then you find the full description. And then here, oh, many hints for you. There's many fields. And also every drop down normally is a table. Selection block drop downs. And and the here's you invite one to many. You feel that architecture here, if the course has many location, many this is combined together, it's like a table and classes. And we extract two more information here, here, and here. And then you click on have a longer detail. Okay, you see the detail view. So here is the very long paragraph. Don't think about extract something here inside, but in the case it may be composite here, you will extract something, but this is a duplicate. And finally, you click on it, go to another website. It's not making sense to model another website, so it should have a URL. Okay, finally, you in this screen you extract location, starting date, and then you the free test is the field, and then start between is calculation. You have the start date and then the duration. This is the field and table you find, and then you should have, but you need to fine tune it and then we think about it when you. But really quite logically, for me, experience, I just write down the data. Maybe maybe in spreadsheet or just manually, then you will find the logic is working or not. Okay, and just think about the drop down. I say drop down. You see the drop down. We got the location, city, and yeah, location, country, city, language. It's drop down, and the delivery mode is better name. Once you extract the drop down, you see this is the logic language field delivery mode. When you drop down, we just for the field level, we just suffix the ID, suffix the ID, suffix the ID to the table. Then you have a large table, and then a very small table join. This is star style. Yeah, star style. And then remember, take up the foreign key. Here is the overview of something you can try to learn and understand, and we try and error to reverse engineer your database from other application, and it's very important for your real world working requirements, since a lot of case bosses just ask you to copy the system from other. Okay, thank you very much.